Hello guys. So today we are going to solve one of the Leetcode problem, which is palindrome linked list. So let's quickly jump to the description of this problem. So given the head of a singly linked list, return true if it is a palindrome. So for finding whether a list is a palindrome or not, so one way is that we convert this linked list into, we copy all the node values into one array. And now if we have to find whether this array is a linked list or not, what we can do, we can use two pointer technique, right? Where we can start from here and the other pointer can start from the end of the list, and we can traverse in forward and reverse direction, right? And we can check whether these two values are equal or not, right? So initially one pointer will be compare, one pointer will be pointing this one and other would be this one. So these two values are equal. Now this one will move forward and this will move backward, right? And that's how we are able to identify whether the list is a palindrome or not. Because in palindromic list, we should be able to divide the list into half, and that half should be mirrored to itself, right? The other half should be mirrored to the other half. But in this problem, if you see what it is asking, could you do it in O(n) time and O(1) space? So definitely that one approach is very straightforward and it's easy to implement. But there we are going to use an extra space, right? An array to store all this node into there, and then we are going to perform that operation. But what if we want to avoid that? So if that is the case, what we can do is the other approach could be, if somehow, right, we divide this linked list into two lists and we reverse the other half of the list. Once this list will be reversed, so one will be pointing to, right? And this is a separate list. Now we can iterate at a time in both lists and we can compare the values. If both values are equal, then we can say these are the palindromic list. And that's how we can save the space as well. So what I'm going to, uh, that's what I'm going to do it here, right? So let's quickly jump to the implementation of the problem because it's a very simple problem. Things will be more clearer to you once I will write the code. Okay. So basically to find the half or the middle part of a linked list, we can use the slow and fast pointer technique, and that's a very standard template, right? So what we do is we define one variable called slow pointer and we define another variable called fast pointer, right? Now we also need to know whether the linked list is okay. Let me come to that part later, right? Let's quickly just find the middle part of a linked list. So this is the standard template, right? What we say that till the fast is there and fast next is there, move slow pointer by one next, right? And move fast pointer by double next, right? By two nodes we are incrementing our fast pointer. So by this time it would be pointing, just give me a second. So yeah, so by this point the slow pointer would be pointing to my middle, right? Now we also need to know whether what is the length of a linked list, right? So for that I will just have a variable length and I will have a temp variable, right? Which will be pointing to head. So how we find the length of a linked list? It's very simple, right? We just iterate over it and find the length, right? So temp will be like temp dot next. So by this time we are having two things. So our slope pointer is pointing to the middle of. So if we see this linked list, right? So the length is 4. So there is no exact middle, but the slope pointer would be pointing this one. So this will be my middle. But if it is like odd, so there is a node. Let's say there is a 3 right here. So this linked list length is 5. So my slope pointer would be pointing 3 here, right? And the length, why we are calculating? Because that's how we will decide how we are going to divide this given linked list. If it is a even length, right? In this case, so my slow pointer is here, right? Pointing. So I should be dividing my linked list. I mean, I should be reversing the linked list, the other half from the next, right? But if it is odd one, if it is odd one, in that case, I have to, I have to, dividing. I have to reverse the string, reverse the linked list from the current node itself, right? What I'm saying is just to give you uh, idea here. So if you see, right, so this is my list and this is my slow pointer, right? So what I'm saying in this case, in the even case, I will reverse the linked list, the other half from the next node. So my next node is 2, right? So this is my another half and this should be reversed, right? So it should be like 2. So this is one half. I don't know, my sketch pen, something is hanging. Okay, so this is another half. But what happens if the list is like this, right? So my slow pointer is pointing here, right? So in this case, I should reverse from here, including the slow pointer. In this case, what I am doing, this is my slow. I am reversing from the next, but here I am reversing from the slow. That's only the part we had to take care, right? I hope you would have got this idea. So if it is a odd length, we have to start reversing from the current one. And the reason for that is that particular odd, the middle part, right? It has to be considered in both, right? Okay, so now let's try to implement the other part of it. What have we have to do is um, now the length is there, so we can use this value if L is equal to, you know, just just to find whether it's a even length or odd length. If it is a even length, I can have a, the current variable which will start from slow next. Else my current should start from slow. Make sense? This is what we discussed. Now in previous, now we have to reverse the other half, right? So how we reverse it, that is also a very standard code for the linked list, right? We take one variable called none, and while my current is there, right? So remember this, my current now pointing to this part, and if it is odd, my current would be pointing to 3, right? So now I want to reverse this. So what I will do is, this is a very standard template, right? So what we do always for the reversing the linked list, from the you take the current next, store into next variable, then you point the current next to previous, okay? And your previous will become current, right? And your current will now will be pointing to the next node, okay? If you don't understand this part, um, there is a very easy explanation on the internet. I mean, you can definitely able to find, but this is a very standard code. So what I'm saying is, if this is my current and this is my next, right? So previous is nothing. There is no previous for, right? Because we are starting from here. So I'm saying, uh, I'm storing. I'm pointing this as a n, right? That's what I'm saying. N is my current next. Now current next pointer has to point to previous, which is null, right? Now previous will become my current and my current will become my n, right? And that's how it will uh, try to reverse all the available nodes into the linked list. Once this is done, so now how it will be look like, our head is still, having everything like 1 2 And since we have reversed it, so still it would be having this 2 is still pointing the 2, right? Though 2 is pointing null. So we have to break this, right? We have to clearly should have a two different list. So what I can do is I know that my slow pointer is still pointing this one because my current started from there, right? So I can say, the slow next should be become none, right? Now this thing got broken. Now we have a clear this list and this reverse list, right? Now simply what we have to do is just iterate over um, your one list which is pointing through head and other list which is pointing through previous, right? And just every time you see that if this value, right, is is not equal to, you can say, the previous value, if that is the case, what you should do, return false, unless you just move forward, right? And finally you can return true. Okay, so this is what the code is. It should, let's see if it is working. So say there's somewhere some error is there. Okay. Okay, so for so for even it is working. Let's quickly test for the odd one. So for odd one also it is working. Let me just quickly submit it, and it got submitted. So that's all for the day, guys. Let me know if you have any question or comments in the comment box. Thank you.